In this video, we are going to talk about joint variation with the ideal gas law, which states that the volume V, given in liters, varies directly with the number of molecules N, given in moles, and temperature T, given in Kelvin, and varies inversely with pressure P in kilopascals. But it also says the constant of variation is noted as R, and it's called the universal gas constant. Instead of using K, they use R, because science likes to be different sometimes. It says write an equation of the ideal gas law and then estimate the universal gas constant. So we are basically going to be estimating our K value based off of some numbers. So at the beginning it says the volume V varies, that's where I'm going to put my equals, directly with the number of moles and temperature. So I'm going to have N times T. And it's capital T, so I have my capital T. But inversely with the pressure P. Means divide by P. The constant of variation is called R, capital R. So that goes on top because that's where my K value would have gone. Okay, now I could have written this nRT over P. I could have written this as NTR over P. Really doesn't make much of a difference. I need a lowercase n, capital T, capital R, multiplied by each other across the top with capital P on the bottom. Now to estimate my universal gas constant, I'm just going to fill in the numbers that I know. So I'm going to have R be something, N is 1, T is 288, P is 9.5. I'm going to just simplify things as I go, as much as I can. So I have 251.6 is equal to 288R over 9.5. I just multiply 288 times 1. First thing I'm going to try to do is if I can just divide both sides by 9, or divide the 288 by 9.5 and get a nice number, I want to. It doesn't work out that way. So I'm actually going to multiply both sides by 9.5. When I do this, 9.5 times 251.6 is going to give me 2,390.2. On the right side, I'm going to get 288 times R because these 9.5s cancel. Then I divide both sides by 288. And we get 8.299305556 in my calculator. Now it says estimate. I don't need to go out to this full thing. I'm going to say this is about 8.3. Okay, if I were to round to the nearest tenth, it would be 8.3. If I round to the nearest hundredth, it'd be 8.30. So 8.3 sounds like a great estimate for my universal gas constant. Have a great day, everybody.